Bismillahirrahmanirrahim. Welcome to the next lecture, which is about the elements and atoms. How can we calculate the average atomic mass, the mole, and Avogadro number, and to differentiate between atomic number, mass number, and isotopes. So let's move to the first one. So here, this is the general representation of the atom. So atom is mainly composed of the electrons, protons, and the neutrons. So this is the total approximately size of the atom, and in which you can see there is a small portion which is exist in the center. It is called the nucleus, and this is the extranuclear part, and all the electrons are present in the extranuclear part, and in the nucleus there are the protons and the neutrons are present. So if you just compare the size of the nucleus with the whole atom, it is much less as compared to the size of the atom. So the size of the atom, let's suppose it is exponent minus 10 meter, and the size of the nucleus is exponent minus 15 meter. So this is the difference between the atoms and the nucleus present in the atom. So here is the other differentiation. Electrons carry the negative charge having the mass of this. Proton carries the positive charge having the mass of this. This is in gram, this is in atomic mass unit. We will discuss in the next slides. So neutron carry no charge, that means it is the zero charge, and this is the mass of the neutron in gram, and this is in EMU. So these are the subatomic particles which are present in the atom. So here we are going to discuss how can we determine the atomic number. So the first difference is the atoms with the elements. Atom is the general term used for any the smallest part of the material. But the element is the substance whose atoms all have the same number of the protons. Like it is the element of carbon, hydrogen, nit nitrogen, oxygen, all these are the elements. So here is the example. Let's suppose this is the carbon. This is the general representation of the element. This is the symbol of the element. This is C. C mean it is for the carbon. And there are two figures are written over here. One is on the lower portion, one is on the above upper portion. In the below portion, it is the represented as the atomic number, and these are the number of the protons present in the element or the atom. So here in the above or the upper portion, these are the number of protons and neutron, and it is called the mass number. So this is the atomic number, this is the mass number. So only proton contribute to the atomic number, while in the mass number, protons and the neutron both contribute to the mass number. So here are the simple formula, that means mass number is the number of protons plus number of neutrons, and atomic number is the number of protons in the atom's nucleus. And of course, there are the same number of electrons as the number of protons are present in the atom, because the net charge on the element is the zero. So proton carries the positive charge, electron carries the negative charge. So number of proton must be similar to the number of the electrons. So this in this slide we have just discussed the representation of the element and atomic number and the mass number. So next, How can you calculate the number of the neutrons? It is the same, like you can use even this equation, and the number of neutrons are the mass number of protons goes to the left hand side and it becomes the minus. So mass number minus number of protons are the number of neutrons. So here, this is the example. Let's suppose an isotope of uranium is this. U is the symbol for the uranium, 92 is the atomic number, and 235 is the mass number. So how can you calculate the number of neutrons? Simply because this is the mass number. Mass number is the sum of the protons and the neutrons, and these are the number of protons. So you just subtract 235 minus 92 will be equal to 143, and these are the neutrons. Very simple calculation. You do not need any extra help to calculate the number of protons and the neutrons, or the atomic number and the mass number. So again, very simple. Number of protons are here. This is the atomic number. This is the mass number contributing to the number of protons and the neutrons. And you just minus the number of protons from the mass number, it will give you the number of neutrons. So coming to the atomic mass now. So what is the atomic mass? It is generally called the atomic mass unit, or also known as the delta, represented by the capital D small a. So because if you know, that is the atom is very small and it is impossible to see the atoms with the naked eyes. So, so what is the solution of this one? We are going to represent in the atomic mass unit, and simply it is called the AMU, and which the value is equal to 1.660 exponent minus 24 gram. So let's suppose this is the example. So the mass of one carbon 612, as we have discussed before, it will be equal to the 12 AMU. 12 is coming from here. This is the mass number, and exactly it will be equal to the 12 AMU. So how we can calculate the 1 AMU? Simply 1 AMU, you have to divide this by the 12, and this is shown here. 1 AMU will be the mass of one atom, carbon atom, divided by 12, and it is the 1/12th mass of the carbon 12. And this will be equal to 1.660 exponent minus 24 gram. So simply 1 AMU will be equal to 1.660539 exponent minus 24 gram. You convert the AMU into gram or gram into AMU. So that's why, because this size is so small, and we will be using the atomic mass unit as compared to the actual mass in gram, because the mass in gram is much small, so we cannot use this to calculate the mass of the atoms of the or the molecules. So next is the average atomic mass. So we have already discussed in the previous example, this this is a symbol for the carbon atomic number, this, and the mass number was the 12. But here you look, this is the atomic mass is written as 12.001. So this is the average atomic mass. So what is the average atomic mass? It is the element's atomic mass is the weighted average of the isotopic masses of the elements naturally occurring isotopes. Let's suppose for in case of the carbon, for example, it is occur on the earth as a mixture of two isotopes. So one is carbon 612, as we have discussed before, but the abundance of 98.89%. This is naturally present on the earth. And the other isotope is carbon 613. Its abundance is much less as compared to the carbon 612, and it is only 1.11% natural abundance present on the earth. This is so. What are the isotope? Isotopes are the nuclide or the atoms having the same number of protons but different number of neutrons. So these two are called the isotopes of the carbon. Why? Because the having the same number of protons, because this is atomic number, this is also atomic number 6. That means number of protons are 6, but the number of neutron in this case carbon 612 is, if you minus 12 minus 6, net will be the 6 number of neutron in case of the carbon 612, but 7 number of neutron in case of the carbon 613. So that's why these are called the isotopes. So again, isotopes are having the same number of protons but different number of neutrons. All these nuclide or the element are called the isotopes. So how can we calculate the average atomic mass? It is just the mass of uh, the concern or the respective isotope multiply its abundance plus mass of the other isotope multiply its abundance. So I'm going to calculate this one. So as we have learned before, the mass of carbon 612 is 12 AMU. So the abundance is 98.89%. You have to divide by the 100. So it will be the 0.9889. So this is the abundance of the carbon 612. So again, the mass of carbon 613 is 13.0037 AMU, and the abundance of this, and you have to divide by 100 to convert into this form. So it will be the 0.0111 abundance of the carbon 613. So if you solve this one, multiply and then plus, it will give you the value of 12.011, and this is exactly which is written here. So here you can see the difference between the atomic mass or the average atomic mass. So atomic average is calculated by using the by considering the all the isotopes of the selected elements present in on the earth. Next, how can you calculate the atoms from mass or the atomic mass? Let's suppose this is an example. So if 1 milligram of carbon is present, then how many atoms are there in 1 milligram of the carbon? So this is the conversion from mass to the atoms. So again, first you have to convert the milligram into the gram, and this you have already learned in the class. So you just have to divide by 1000 to convert the milligrams to the gram. So it will be 1.00 x minus 3 gram. And this is the factor we have already discussed before. 1 AMU will be equal to 1.6605 x minus 24 gram. So you have to put this in the denominator, and this will be the numerator, because numerator, because you have to cancel the gram with the gram. So if it is cancelled out, the remaining will be the atomic mass unit. So because this is the the mass of carbon, so one carbon atom will be equal to 12.011 atomic mass unit, as we have calculated in the previous slide. So again, I am putting as a denominator here, and one carbon atom is numerator, just to cancel out the AMU with the AMU. And if you solve this one, the whole value will be 5.01 exponent 19 carbon atoms, because this is the only left over here. So these are the number of atoms of the carbon present in 1 milligram of the carbon. So this is the conversion, how you can convert 1 gram or any mass of the element to the number of atoms. So moving to the next slide now, what are the molecules? So molecules, as you know, these, if two or more than two atoms are present or the elements are present, and uh, these are called the molecules. So molecules actually is the combination of more than two atoms of the element. So this is C2H4 ethylene. It is called the molecule. HCl hydrochloric acid, a molecule. C2H5Cl, this is called the ethyl chloride. It is also called a molecule. So how now you can, first we have calculated the atomic mass, the mass of the atom. Now we are going to calculate the mass of the molecules. So simple, in the same way, the mass of the molecule is the sum of the masses of all atoms in a molecule. So let's suppose the first example is C2H4. There are two atoms of carbon and four atoms of hydrogen. So two atoms of carbon, four atoms of hydrogen, and mass of one carbon is 12 and mass of one hydrogen is 1. This you can take from the periodic table. So no need to worry. I have already given to you in the exercise the atomic number or the mass number, and you can also take it from the periodic table. So you just multiply 2, it will be 24, multiply by 4, it will be 4. So two carbon atom having the mass of 24, 4 hydrogen atom having the mass of 4 AMU, and you just sum up, this is 28.0 atomic mass unit. So this is the molecular mass of the ethylene C2H4. In a similar way, you can calculate the C2H5Cl. Here, there are 2 carbon, 5 hydrogen, and 1 chlorine. Again, the mass of the 1 carbon is 12, and for the 2, you have to multiply by 2, it will be 24. Mass of 5 hydrogen, 5 into 1, 5, and the mass of 1 chlorine is, because this is the 1, so the 1 chlorine atom having the mass of 35.5, you should sum up and it will give you the value of 64.5 atomic mass unit. So this is the molecular mass of the C2H5Cl. In a similar way, you can calculate the molecular mass of the Cl and the NaCl. So simply, you just sum up the masses of all atoms in a molecule, that will give you the value of the molecular mass. So now here you will learn to calculate the Avogadro number and the moles. So one mole, by definition, one mole of any substance is the amount whose mass, particularly its molar mass, is equal to the molecular or the formula mass of the substance in grams. So I will explain in detail. So you just have to look the definition of the Avogadro number. So 1 mole of any substance contains 6.02 exponent 23 formula unit, and this value is called the Avogadro number. This is very similar to the, if you use the terms dozen like 1 dozen of orange, 1 dozen of eggs. So here we will use the Avogadro. So Avogadro is the actually giving you the figure, that means 6.02 exponent 23 of any unit. So here is the example. This you have already calculated or we have already calculated in the previous slide. The molecular mass of the HCl is 36.5, and this is also called the molecular mass of the HCl in 36.5 gram. So these are the same thing. So molecular mass if of HCl is 36.5 as we have calculated before, that means it is 36.5 gram of HCl, and this 36.5 gram actually it is called the 1 mole of the HCl, and in this 1 mole of the HCl there are 6.02 exponent 23 HCl molecules. So 1 mole of HCl equal to 36.5 gram of HCl equal to 36.5 AMU of HCl. These are the same thing, and these, that means 1 mole of HCl, 36.5 gram of HCl contains how many molecules? 6.02 exponent 23 HCl molecules. So what I have done over here, I have just multiplied 6.02 exponent 23 to the 1, because 1 mole of the molecule equal to these one. 1 mole of the any molecule equal to 6.0223 HCl molecules. So let's pose another example. This is in the same way you can explain. This is the molecular mass of the C2H4. It is same, that means 28.0 AMU will be equal to the same 28.0 gram, and this 28.0 gram will be equal to 1 mole of the C2H4, because this is the molar mass, that means it is 1 mole. So 1 mole containing 28.0 gram of the C2H4. And how many number of molecules are present? These are the number of molecules are present in 1 mole of the substance. So here, if you have a look on all these calculations, 1 mole of NaCl, 1 mole of C2H5Cl, 1 mole of C2H4, 1 mole of HCl, all having the same number of the molecules, and this is equal to 6.02 exponent 23 HCl molecules, and this is called the Avogadro number. In the same way that if you just ask, or you can ask, you just designate 1 dozen of X, these are equal to 12. 1 dozen of orange, these are also equal to 12. In a similar way, this is the term used for the number of atoms of the molecules to, to represent in the Avogadro number. So let's see some few of the examples. Again, I'm going to show you the calculation of molecular mass. So here the screws molecule is given, having the formula of C12H22 and O11. So again, there are 12 carbon, and each carbon having the atomic mass unit of 12. There are 22 hydrogen, and each hydrogen having the mass of 1. 11 oxygen, and each oxygen having the mass of 6. You just multiply, and this will give you the value, and sum of all these atomic mass units give you the value of 342.0 atomic mass unit. So this is, that means this is the molecular mass of the this sucrose molecule. We're having, or you can represent here 342.0 AMU, or you can say 1 mole of the sucrose has the mass of 342.0 gram, or you can say the molecular mass of the sucrose is 342.0 gram per mole. So all these three are the same terms used to represent the molecular mass of the sucrose. Another example, now you can convert the mass to the number of moles. So again, in the previous example, you have already calculated the molecular mass. So let's suppose this is a simple the sugar. If I ask you, you have 2.85 gram of sucrose or the sugar. So what will be the number of moles of the sucrose present in 2.85 gram? So it is very simple. 2.85 gram you can take, and this is the ratio you already have calculated in the previous example. That means 1 mole of sucrose will be equal to 342.0 grams sucrose. So I'm going to cancel out this one. The rest is 1 in moles, and this the value will be equal to 0.00833 moles of the sucrose. Or you can just to convert into the short form, because if you move this point to the here, so it will be converted into exponent minus 3, because you are moving to the by passing the 3 digit towards the 8. So 8 point, you can simply say 8.33 exponent minus 3 moles of the sucrose. So just this is the unit cancellation method, as you have already learned in the classes. So you just use the this formula, or simply now the simple formula for the mole is the mass divided by the molecular mass. This will directly convert the gram or the mass to the moles of any molecule. Another conversion. Now it may be the reverse calculation, conversion of mole to the mass. Here I am giving you another example. Let's suppose 0.0626 moles of sodium bicarbonate are given, NaHCO3. So you have to convert to the mass by using these number of the molecules. So very simple. The first, you need to have a molecular mass of the sodium bicarbonate, and simply you can calculate by using the previous example. There are one sodium, one hydrogen, one carbon, and three oxygen. So one sodium is 23, one hydrogen is 1, one carbon having the atomic mass unit is 12, and one oxygen having the mass of 16, and there are three oxygen. You just multiply and sum up, it will give you the value of 84.0 atomic mass unit. And what is this? This is the gram per mole, or it is called the molecular mass of the sodium bicarbonate. So again, 0.0626 moles are given, and you have to use this ratio, and here 1 mole will be equal to this. Why I am putting 1 mole in a denominator, because I have to cancel out the number of moles to the moles. So just to cancel out this one, because opposite will cancel out this will, and you can solve this one. This will give you the value of 5.26 gram of sodium carbonate NaHCO3. So in this slide, you can convert the number of moles to the gram or the mass by using this conversion. So I'm just now concluding, and this is the exercise I have already given to you. I just picked up the first 6 one. I'm going to solve this one. So watch carefully, listen carefully, how to convert, how to fill up the correct answer in the exercise. So first one is the how many moles of sodium are in 42 gram of the sodium. So sodium, it is the atomic AMU of the atomic mass unit of the sodium. It is given. If it is not given, you can also take from the periodic table. So how can you convert the gram into moles? Simply you have to divide the 42 with the 23. This will give you the value of 1.8 mole of the sodium, and in the similar way what we have already calculated in the previous slide. So the next example is how many moles of oxygen are there in 8.25 gram of oxygen. This is the atomic mass unit of the oxygen. Again, the weight is given. You have to divide the weight with the atomic mass unit, or the, and this will give you the value of 0.515 mole of the oxygen. So simply given mass divided by the molecular mass. Here is atomic, because these are the atoms. So you can divide the atomic mass unit of the sodium and the oxygen. And the third example is how much does 2.18 mole of copper weigh? That means you have to convert the weight, and now the number of moles are given. So how can you calculate? Simply you have to reverse this ratio. You just multiply this AMU with the number of moles, and this will you directly give the value of 138.43 gram of copper. So you are multiplying 2.18 with the 63.5 in the same way as I have shown you in the previous slides. So the fourth example is what is the mass of 0.28 mole of iron. This is just the change in language, but it is the same. The number of moles are given, and you have to calculate the mass. And simply, how can you calculate? You just multiply the moles with the 56 AMU, and this will give you the value of 15.68 gram of iron. Fifth example is how many atoms are there in 7.2 moles of the chlorine, and this is the atomic mass unit of the chlorine. So again, the number of moles are given, and here in this example, if the number of moles are given, then there is no need to use this atomic mass unit, because I have already given you the number of moles. So you directly, how can you convert the number of moles to the atoms? Because 1 mole will be equal to 6.02 exponent 23 at atoms. So you just have to multiply the Avogadro number with the 7.2, and this will give you the value of chlorine atoms. So just multiply 7.2 with the 6.02 exponent 23. In the sixth example, how many atoms are there? 36 gram of bromine, and atomic mass unit of the bromine is 82. So how can you convert? No, because the weight is given, and the first you have to convert this mass into the moles, and then you multiply this Avogadro number, which is 6.02 exponent 23, and that will give you the answer. So here, what you have to do, first you have to divide 36 by 80. This will give you the number of moles, and then you have to multiply with the Avogadro number, which is 6.02 exponent 23, and this is the answer of this problem, 2.7 exponent 23 bromine atoms. So in a similar way, you can calculate the rest of the problems. So this is all about the number of atoms, the atomic mass, atomic number, and average atomic mass, and how can you convert the moles to the atoms or the molecules, or from molecules or moles to the atoms. And this is all about the learning in this lecture, and by using this, now you can solve the exercise which I have already given to you. Thank you for watching the video.